Welcome back. Warm welcome to all the participants in this session. Okay, so we are back with GATE Champion Series. In this GATE Champion Series, we'll approach many important portions of the GATE and we will solve fresh new questions. Okay, those questions will not be previous year questions. Some of them might be like previous years, but they will be fresh questions and we'll be completing very important topics. So we are starting with what? Geotech. And today we'll be seeing what? The tough topic of shear strength of soil. Let us welcome all the participants. Welcome Juhi, Raja, Nikki, Bijit, Naividya, Lakshmi, Civil Service Examination, Samriddhi, Kartike, Rasmita, Akshay, Sainbok and Surya Prakash. So warm welcome to all of you. So my name is Satyajeet Sahu. Those people who are seeing this lecture recorded, for them also it's warm welcome. Okay. So in this particular series, we are going to cover these lectures and I am going to cover these lectures. Okay. So first of all, in Geotech, first 4 days, 31st to 3rd, I will be completing different topics of Geotech. Then from 6th to 9th September, we have fluid mechanics. Okay. From 15 to 16, I will be covering surveying. Okay. 21st and 22nd, I will be covering steel structures. 27th and 28th, transportation. Okay. And then 29th and 30th, hydrology and irrigation. So all these topics we are going to see one by one. So this month will be jam-packed. So I hope all these sessions you will attend. Okay. And all these lectures will be at 10:45 p.m. So you can study in the daytime and night time you can come for revision and understanding the concept. So we'll be solving numericals, but before solving the numericals, we will see what? The basic theory. And we'll be solving two types of questions. Some questions will be straightforward theoretical questions and then some will be numerical. And then I'll be giving you 4 homework per day. Every day I'll give you 4 homeworks. Okay. So first of all, we'll be covering Geotech. In Geotech, today we'll be covering shear strength of soil, right? Stability of slope, earth pressure and foundation engineering. So they are tough topics, right? These are tough topics which most of the students find difficult. So therefore we'll be covering them in this particular champion series. Thank you very much. Let us start the session without any further delay. So welcome Fariha, welcome Aftab and welcome Siddharth. Okay. Let us start the lecture. So first we'll see what are the topics which we'll be seeing in today's lecture. We'll be seeing first of all Moore Coulomb failure criteria. Then we'll be covering triaxial test. In triaxial test, a tough topic, right? Then Vane shear test, and at last we'll be seeing what? Pore water pressure parameters. This is what I can say the index. Okay. So let us start with what? Shear strength of soil. So I can say that the shear strength of soil is the shear stress at which soil fails. Now the shear strength of soil is given by the equation what? Shear strength is equal to the normal stress into 10 phi plus C. Yes. So it depends on 3 parameters. It depends on the normal stress. It depends on normal stress. It depends on phi. What is phi, by the way? It is the angle of internal friction. I can say angle of friction of soil. And C is what? C is the cohesion. C is the cohesion. Now if I am plotting, this shear strength versus this normal stress, yes, then you can see it's an equation of straight line, right? You can see it is what? Y is equal to mx plus c. It is the equation of straight line. Yes, equation of straight line. So I will get a plot like this. I'll get a plot like this, yes. And this will be what? The shear strength is equal to the normal stress into 10 phi plus c. Now in this equation what happens? In this equation what happens? You can see that the normal stress 10 phi plus c. Now see, this cohesion is also the intercept of the equation what? Y is equal to mx plus c. It is also the intercept. So in this particular graph, this value will be equal to what? The cohesion value of soil. Now see in this, what is the slope then? What is the slope? Tell me, what is the slope? Tell me. What is the slope? What is the slope? The slope is 10 phi, right? When the slope is 10 phi here, from this equation you can see, when the slope is 10 phi, that means what? The angle of this particular shear strength, yes, with respect to horizontal will be what? It will be simply phi. Okay, so everybody understood what? This shear strength of soil. Yes, and this is known as what? The shear strength envelope, or also known as the failure envelope. We'll understand this further, but before that, let us see some basic questions. Let us see some basic questions. So answer this question now. Some basic questions, okay? Basic questions, and then we'll be moving into little tough questions. But first, basic 1 mark questions which can be asked. Then we'll be moving to the 2 mark questions also. So basic question number 1. Please answer. What is the answer to this? What is the answer to the shear strength of soil depends on what? It depends on all of them, right? It depends on the normal stress. It depends on the angle of internal friction. It depends on the cohesion. So all of these. Now the next question, right? So answer this question. Again, a very basic 1 mark question. This can be what? A 1 mark question. So please answer this question. Please answer this question. So we'll be seeing some basic 1 mark question, and we'll be seeing some tough questions also. But first we will start with some basic equations, right? Please answer this question. In the C5 soil, cohesion value is given, right? Cohesion is given. Then the phi is given. Phi is given 30 degree. So please answer this question. What is the correct answer? Let me also solve this. D88. Okay, very good. So you see the shear strength equation is what? It is the normal stress into 10 phi plus C. So normal stress is given 100, right? Then 10 30 plus C is given again 30. So 10 30, okay, multiplied by 100, okay, plus 30, I am getting 87.73, close to what? 88. They are what? Very basic questions, okay. Now let us understand something about the principal stresses. Principal stresses. Suppose this is a soil element. This is a soil element, okay, soil element. In this soil element, the vertical stress will be the major principal stress. The major principal stress. The vertical stress will be what? It will be the major principal stress, okay. The vertical stress will be the major principal stress, and the horizontal stress will be the minor principal stress. It will be what? The horizontal will be the minor principal stress. It will be minor. So I can write down in bracket what? Minor, and this I can write down as major. So obviously sigma 1 will be greater than what? Sigma 3, because sigma 1 is the major one and sigma 3 is what? The minor one. Now what happens when these stresses are applied on the soil element? The soil element will be inside the soil, right? The soil element will fail, right? There will be shear failure, right? And this will be what? It will fail like this. It will fail something like this, right? It will fail something like this. And this is known as what? This is known as the failure surface. This is known as what? The failure surface. This is known as what? The failure surface. On this failure surface, there will be some normal stress, right? And there will be some shear stress, right? Now this normal stress will be known as what? The normal stress on failure surface, and this will be known as what? The shear stress on failure surface. Understood? I got admission in this. Okay, yes, we will discuss those things, but let us not go into these things because we are now studying something very serious. So let us first focus on the topic. At the end, I will take questions, okay? At the end, I will take questions, okay? So this is the failure surface, and this failure surface is making an angle of alpha f with the horizontal. You see, this is the horizontal. This is the horizontal, right? So this failure surface is making an angle of how much? Alpha f, okay, with the horizontal. And this alpha f is known as what? This is known as the failure angle. Now this failure angle is with what? With the horizontal. Now you see, on this horizontal plane, this sigma 1 is acting na. Sigma 1 is acting na. So can I say this horizontal plane, Okay, can I say this horizontal plane is also the major principal plane? Yes, this horizontal plane is also what? The major principal plane, and I can say that this particular angle alpha f, the failure angle, is making with what? With the horizontal, or I can say the major principal plane. Everybody understood this concept? Yes. Now let us understand this graphically. Let's understand this graphically, right? Now see on that stress element, I can say this is the major principal stress. Yes. This is the minor principal stress. Yes. Now we just saw the shear strength line. Yes. This will be the shear strength line. Yes. This is what? This is equal to sigma n tan phi plus c. C. Yes. And this will be your cohesion. This will be your cohesion. Yes, very good, very good. Now you see, wherever this shear strength line intersect this Mohr circle, that will be the failure point. This is what? This is the failure point or failure plane. Okay, this is the failure plane. Now if I want to see the angle of failure plane with the major principal plane, you see, here in this diagram, this was the failure plane, right? This was your failure plane. It was making alpha f with the major principal plane, right? With the major principal plane. Very good. It was making alpha f, right? Now remember that, anyhow you have understood in Mohr circle. If you have not understood, remember that whatever angle we see in the stress element in the Mohr circle, it becomes twice. It becomes what? Twice. So tell me, this is the failure plane. This is the major failure plane. What will be this angle? Tell me. Please write in the comment section. Okay, this is the diagram. In the diagram, the angle between the failure plane and the major principal plane is alpha f. And I told that whatever angle we get in the diagram, in the Mohr circle, I get the twice. So if this is the failure plane, every point on the Mohr circle indicates the plane. So if this is the failure plane and this is the major principal plane, yes, this is the major principal plane. So this will be 2 into alpha f. Very good. Okay, this is what? 2 into alpha f, right? Okay, now this is 2 into alpha f. Everybody understood it? Now this angle is what? Tell me. What is this angle I am indicating? Please write in the comment section. What is this angle? What is this angle? Tell me. What is this angle? I have explained some time before. This is what angle? Tell me. Phi. Very good. This is phi. If this is phi, I can say this also will be phi, right? This is phi. This also is phi, right? The slope, the inclination of this line, I have extended this line, this shear strength line, right? Okay, so this is phi. Now this is 90 degree. This is 90 degree because it is just touching. It is 90 tangent, 90 degree. So this angle will be what? 90 minus phi, right? This angle will be 90 minus phi. Now from this, I can write down what? 90 minus phi plus 2 alpha f is equal to 180 degree, right? Everybody understood this? Yes. 90 minus phi plus 2 alpha f is equal to 180 degree. How I got this? This is phi. So this is phi, right? This is 90 minus phi. Understood? So from here, I can write down 2 alpha f will be equal to 180 minus 90 plus phi. I just took this the other side. So this become what? 90 plus phi. So from here I get a very important relationship that the failure angle is what? 45 plus 5/2. Everybody understood from where we got this relationship? Alpha f, the failure angle, the angle between the failure plane and the major principal plane or the horizontal plane is how much? Alpha f equal to 45 plus 5/2. The derivation is not important, but the understanding will be good for your remembering. Okay, so now solve this question. Okay, solve this question. So before that, this is alpha f, sigma 1, right? and this alpha f is sigma 3, and this alpha f is nothing but 45 plus pi by 2. Understood? So, the angle between the failure plane and the horizontal, this is horizontal, or I can say what? The major principal plane is 45 plus pi by 2. Let us solve this question. Please solve this question and tell me the answer. Please solve this question and tell me the answer. Now, these are objective questions, 1 mark questions. The 2 mark questions will start, don't worry. But before that, we are solving the basic questions. Before that, we are solving the basic questions. Then we'll go to the tougher ones. Please answer. Now, in triaxial test is given, just understand is a failure angle is given. Okay, some people have answered C, very good. C, very good, yes. You see, alpha f is given how much? 61 degree. And this is nothing but what? 45 plus 5 by 2. So from here, I can say 5 by 2 is equal to 61 minus 45, that is equal to 16 degree. And from here, 5 is equal to how much? 32 degree. So now everybody understood how we got that relationship, right? And from there, we solve this question. Now, let us see the very important relationship. I will not derive the relationship. This relationship is very important for solving the questions of shear strength. This is the relationship between what? Sigma 1, the major principal stress, and the minor principal stress. This is equal to sigma 3, 10 square, 45 plus 5 by 2, plus 2c 10 45 plus pi by 2. It's a very important relationship. This relationship is, I can say, most important equation of what? Your shear strength chapter. And from here I can say sigma 1 is equal to, you see, sigma 3. You see this 45 plus pi by 2 is alpha f na. So I can write down what? 10 square alpha f plus 2c 10 alpha f. This form is little easy to remember, right? Yes. Now, this 10 square, 45 plus pi by 2 can also be written as what? 1 plus sine phi by 1 minus sine phi. Yes. This 10 square, 45 plus pi by 2 can be written as what? It can be written as 1 plus sine phi by 1 minus sine phi. Very important relationship. Yes. So this equation is very important in solving the questions. Now you see, in a cohesionless soil, what will be 0? Tell me. In cohesionless soil, what will be 0? Tell me. C will be 0, obviously. It's a cohesionless soil. So if it is a cohesionless soil, the equation will change, na? It will become what? The major principal stress will be equal to sigma 3 10 square 45 plus 5 by 2, because I can say the other term vanishes. The other term vanishes, right? So from here, I get a very important relationship. What is that relationship? Let us see. So now I can say for cohesionless soil, your sigma 1 is equal to sigma 3 10 square 45 plus 5 by 2, or I can say 10 45 plus 5 by 2 will be equal to root under sigma 1 by sigma 3. Yes? Yes? So if I ask you a very simple question, Suppose I am telling a relationship that cohesion is 0, and I am saying that sigma 1 is 4 times sigma 3. Find the angle of internal friction. Can you give me this particular answer? Find angle of internal friction. Please solve and give me the answer. The angle of internal friction. Please solve and give me the answer. There is no options. Okay. So please solve and give me the answer to this. I will also solve for you. Very good, Aftab. Very good, Aftab. Others, Karthika, very good, very good. You see, by understanding simple equation, you can solve these questions very fast. You see, it is given cohesionless. So this equation will be valid, right? So here I can say 10 45 plus 5 by 2 will be equal to root under, in place of sigma 1, I can write down 4 sigma 3. 4 sigma 3 by sigma 3, it get cancelled, I get a 2. So from here I can take a tan inverse, and 45 plus 5 by 2, I'll take tan inverse 2, right? I'll take what? Tan inverse 2, I'm getting 63.44. 63.44, and from here I can get the phi. You see, most of you were able to solve by just having this basic understanding, right? Most of you were able to solve this question by just having this basic understanding. Okay, now I will give you another equation also. I will give you another equation. I'll give you so many equations. Okay, I'll give you so many equations. I can say they are the hacks. They are what? The hacks to solve questions in the GATE examination. You need to be smart, right? You need to be smart. Okay, now you see. This 10 45 plus 5 by 2, I can write down what? See, 10 square, it will be this one, right? So 10 square 45 plus 5 by 2, I write down what? 1 plus sine phi by 1 minus sine phi. This is equal to what? Sigma 1 by sigma 3. If I cross multiply, I get sigma 3 plus sigma 3 sine phi is equal to sigma 1 minus sigma 1 sine phi. If I take all the sine phi terms one side, right? It will become what, you see? I will take this side, it will become what? Sigma 3 plus sigma 1 is equal to sigma 1 minus sigma 3, and here common will be sine phi. So from here what I can say? Sine phi will be equal to sigma 1 minus sigma 3 by sigma 1 plus sigma 3. Another beautiful equation. Now tell me, I can apply this equation to all the types of soil, or is there any specific condition? This equation I can apply to all the types of soils, or there is any specific condition? Tell me, write in the comment section. I can apply this to all the types of soil, or is there any specific condition for this? Please mention in the comment section. Is this equation valid for all the type of soil, or a condition is there? What is the condition? Yes, very important. It is only applicable for cohesionless soil, or I can say sand. This equation you cannot apply for general C5 soils. You can only apply for cohesionless soil or C is equal to 0 or sand. Let us solve a question now. Please solve this question then. Please solve this question. Easy question, but solve it. Come on, who will answer first? Kisan Chaudhary, I will answer your question at the end of the lecture, because we are in middle of a lecture, so I don't want to disturb the flow of the lecture. I will definitely answer your question. So please wait till the end. At the end I will answer. I don't want to disturb the flow. Sorry. Okay. Karthik is telling stress path concept. We'll discuss at the end. First let us concentrate on the basic concepts. Okay. 30. Very good. So sine phi is equal to what? Sigma 1 minus sigma 3 by sigma 1 plus sigma 3. Right? Now see, it is written what? The difference of the principal stresses is what? It is given half of their sum. Right? It is half or their sum. So when we use this, we are getting what? This is 0.5, and you need not find out sine inverse. You know that sine 30 is 0.5, right? So answer is what? 30. Yes? So you're able to solve this question. You're able to solve this question by just knowing that basic concept. Let us put some more light on this particular thing. Let us put some more light. Okay? What is that light? Okay. Now you see soil. Suppose this is soil, ground level, right? Now we have a soil element here. So what happens when a soil element is there? Then what will happen? There will be stresses on this from all sides. Yes, and this stress will be equal. This stress will be equal, right? the stress will be equal. Yes, that stress, suppose I am calling it as confining stress. That stress I am calling as what? Confining stress. Yes, and this stage I am calling as what? Consolidation stage. I am calling what? The consolidation stage of soil. So in consolidation stage, I can say that we have a stress element like this, and we have what? Confining stress acting from all sides. We have a confining stress acting on all sides. This is what? Soil. A soil element in soil. A soil element in soil. Now what happens? In this consolidation stage, we can have two conditions. Suppose this is the ground level. Right? And this is a soil element. Okay, this soil element. Now this particular soil element can have conditions of what? Drainage or no drainage. It can have condition of what? Drainage or no drainage. So when drainage is possible, whenever drainage is possible, the soil will consolidate or not consolidate. Please mention the comment section. If there is drainage possible, tell me, the soil will be known as consolidated or unconsolidated. Please write in the comment section. When I'm saying drainage is possible, I'm taking means what? Drainage is possible. The soil will consolidate or not consolidate. Please tell me. That means soil will consolidate. Yes, I'll call this as what? Consolidated. Why? Because drainage is possible. Drainage possible means what? Consolidation can happen, right? Because consolidation depends on drainage is possible or not. Now tell me, when I say drainage is not possible, when I say drainage is not possible, the soil will be called as what? Tell me. When the drainage is not possible, the soil will be called as what? Tell me. It will be called as unconsolidated. Everybody understood? So in the consolidation stage, when I am having what? Confining stress all over, I can have two conditions. Drainage possible, consolidated. Drainage not possible, unconsolidated. Easy. Now the next stage is shearing or deviatoric stress stage. What is the meaning of this? See, we have this ground level, and then this is the soil element. Before this shearing or deviatoric stress stage, what was there? There was confining pressure or confining stress all over. There was confining stress or confining pressure all over. Now, suppose in the soil and consolidation was happening. Now, suppose at the ground level there is some load coming. There is some additional load coming on the ground level. Okay, some additional load. Now this additional load, okay, this additional load will lead to what? Increase in the vertical stress, right? And that increase I will call as what? Sigma D or deviatoric stress. This is known as what? Sigma D or deviatoric stress. And this comes in what? When the additional load is applied at the ground level. And here also there will be increase in the vertical stress. Now this situation is very similar to that, right? Where we have what? Major principal stress in the vertical direction, right? And minor principal stress in the horizontal direction, right? And this stage is known as what? Deviatoric stage. And at this stage, what will happen? The soil will fail here. And tell me, what will be this angle? Tell me, what will be this angle? Tell me, what will be this angle? What will be this angle? Tell me, what will be this angle? Yes, alpha F. Very good. Yes, alpha F. Very good. Okay, very good. And in this particular shearing or deviatoric stage, shearing or deviatoric stress also we can have two conditions. If the drainage is possible, I will call this as drain test or drained condition, and if drainage is not possible, I will call what? Undrained. I'll call what? Undrained. If I summarize this, if I summarize now, I can say that first of all, we'll have what? Consolidation stage. In consolidation stage, we have confining pressure acting all around, right? It is equal. And in that particular consolidation stage, I can say if drainage is possible, consolidated. Drainage is not possible, unconsolidated. हिंदी में बोलेंगे तो क्या बोलेंगे कि consolidation stage में क्या हो रहा है कि आपके सॉइल एलिमेंट पे ऑल अराउंड सेम स्ट्रेस लग रहा है, और उस स्टेज में अगर ड्रेनेज पॉसिबल है तो consolidated, नहीं है तो unconsolidated, right? And then in the shearing or deviatoric stage, additional stress is coming at the ground level, due to which there is increase in the vertical stress. That increase in vertical stress or the additional stress is known as what? That is known as the deviatoric stress. And due to that, soil will fail. At how much angle? Alpha F with the horizontal. And this shearing or deviatoric stage can also have two conditions. If drainage is possible, then drained. Not possible, undrained. Understood? ओके, इंग्लिश समझ नहीं आती और गेट की प्रिपरेशन करनी है, सो यू कैन कम टू आवर, यू कैन जॉइन आवर बैचेस. इन बैचेस वी हैव बोथ इंग्लिश एंड हिंदी. So in our BYJU'S Exam Prep batches, we have both English batch and Hindi batch. Okay. Now, based on this, we have three type of conditions. We have three types of conditions: UU, CU, and CD. You see, in case of consolidation stage, we have two combinations, right? If drainage is possible, consolidated. Drainage is not possible, unconsolidated, right? And in case of deviatoric stage, we have two conditions. Drainage is possible, drained, right? Drainage is not possible, then undrained, right? So when I say UU, okay, when I say UU, this is what? Unconsolidated, what? Undrained. Unconsolidated, undrained. Yes. Now tell me, when I am writing unconsolidated, undrained, tell me, drainage possible in which stage? Drainage possible in which stage? If I am writing unconsolidated and undrained, drainage possible in which stage? It is not possible in both the stages. Therefore, unconsolidated and undrained. Therefore, what? Unconsolidated, undrained. Then what? CU. CU means what? Consolidated, undrained. Consolidated, undrained means what? I can say drainage is possible in the consolidation stage, but not possible in the deviatoric stage, right? And when I say consolidated, drained, consolidated, drained, then what? Both stages it is possible. Both stages it is possible. We don't have this condition. This condition don't exist in real life. Means what? First drainage was not possible, unconsolidated, and then it started draining. That is not possible. So this is not a possible combination. So everybody understood the basics of what? All these type of conditions. UU condition, CU condition, and then CD condition. Now answer some basic one mark questions. Okay? Answer some basic one mark questions, and then we will come to our triaxial test. Okay? So this triaxial test is nothing but these basic conditions only. So please answer these conditions. Okay? Okay, not this. Answer this. Answer this. Answer this question. Very good. CU. CU means what? Consolidated undrained. CU means what? Consolidated undrained, right? That means consolidated means what? Drainage is possible. Undrained means what? Not possible. So you see the first one is the consolidation stage and therefore drainage is possible only in consolidation stage. Very good. Now answer the next question. Answer the next question. During CD test on a saturated soil sample, drainage is allowed during a CD test on a saturated soil sample, drainage is allowed during. Come on. What is the answer to this? Very good, Kartike. Very good. Very good. Very good. Answer is C. CD. Consolidated. CD means what? Consolidated and then drained. Consolidated and then drained. So, consolidated means what? Drainage is possible. Drained means what? Drainage is possible. So, sorry, both the stages. Now answer this little tricky question. Come on, let us see who will answer this. Deviatoric stress acts during which stage? Let us see. Let us see. Yes. Yes, it is only during the shearing stage, or I can take deviatoric stage. So if I summarize this condition of the soil, in the consolidation stage, there is what? Only sigma C acting, right? Only confining stress is acting at the consolidation stage. And in consolidation stage, I can have two conditions, consolidated or unconsolidated, right? In the shearing stage, the additional deviatoric stress will come into picture and then the soil will fail. The soil will fail. That means the deviatoric stress acts in the shearing stage or the deviatoric stage, the second stage. And in second stage, drainage is possible, then drained. Drainage is not possible, then undrained. Yes. Now you see, this is the real life condition, right? This is the real life condition. Now, we try to replicate the real life condition in the laboratory, right? This real life condition we try to replicate in the laboratory. Why we try to replicate in the laboratory? Because if you replicate in the laboratory, then what I will get? I will get this alpha F now. If I get this alpha F, this is what? 45 plus 5 by 2. Yes? So if I get this 45 plus 5 by 2, I get the phi. I get the angle of internal friction of the soil. Yes? Understood? To find out this shear parameters, shear strength parameters, phi, I do test, and that test is known as what? Triaxial test. That one is what? Triaxial test. Let us see triaxial test now. Let us see triaxial test. So in triaxial test, what we do? We try to replicate whatever happens in the real life. So what we do? First of all, this is a setup. This is the soil sample. This is the soil sample, right? And it is surrounded by what? A cell, a chamber in which water is there. Water is there, yes? And you can maintain a pressure here. You can maintain a pressure. So you can maintain a pressure. So in the consolidation stage, which stress will act, tell me? In the consolidation stage, which stress acts? The confining stress acts, right? In the consolidation stage, the confining stress acts. Yes? All around there will be equal stress, right? So all around there will be what? There will be equal stress acting on this soil sample. All around there will be equal stress acting on this soil sample, right? And you can control the drainage. You can control the drainage by this valve, right? So if you open the valve, it will be known as what? If you open the valve, consolidated or unconsolidated? When the valve is open, consolidated or unconsolidated? Please write in the comment section. When you open the valve, consolidated or unconsolidated? Please write in the comment section. When you open the valve, consolidated or unconsolidated? Come on, come on. Yes, consolidated, because when you open the valve, then the drainage is possible. Drainage is possible means what? Consolidation, consolidated. That means you are trying to replicate the real life conditions in the laboratory. Right? Very good. Now, this is the consolidation stage. In the deviatoric stage, already what will be there? Already the confining pressure will be acting all around. Yes, already the confining pressure will be acting all around when we go to what? The deviatoric stage. When we go to this deviatoric stage, already the confining pressure will be acting all around. Right? All around. Now, what we'll do? We'll apply what? Additional stress. You can see this is the additional axial load is applied. Additional axial load is applied. And due to that, there will be development of what? Deviatoric stage. Deviatoric stress. Now this deviatoric stress can also be named as what? Additional axial stress, right? This can be also known as what? Additional axial stress. Additional axial stress, right? And then this additional axial stress will come into picture, right? And then here the soil will fail like this at alpha F in the shearing stage, or I can say deviatoric stage. Here also we have valve and I can control the drainage. If the valve is, tell me, if the valve is closed, what I will call this? If the valve is closed, what I will call this? Tell me. If the valve is closed, what I will call this? Tell me. If the valve is closed, what I will call this? Tell me. Undrained. Yes, because it is shearing or deviatoric stage. It is shearing or deviatoric stage. If the valve is cold, drainage is not possible, then undrained. Understood? Yes. So this is how we conduct the triaxial test. In triaxial test, yes, we have many advantage. How? We are replicating what? The real life conditions, right? We are replicating the real life condition and getting what? The shear strength parameters. So these questions we solved. Now we will solve some tough questions. Now we will solve some tough questions, but before that, some more theoretical understanding, right? Some more theoretical understanding. So, first of all, in the soil element, there will be this confining stress acting, right? There will be this confining stress acting like this, right? Confining stress acting like this, okay? And then the additional deviatoric stress, sigma D. So now if I want to say that this vertical stress is your major principal stress, this vertical stress is what? The major principal stress, right? And the horizontal stress is the minor one. So from here I can say what? The major principal stress is nothing but the confining pressure and the deviatoric stress, right? The confining pressure and the deviatoric stress. This confining pressure is also known as chamber pressure or cell pressure. Why? Because it applied inside a chamber or cell. So it is also known as what? Cell pressure, confining pressure or chamber pressure, right? And your sigma 3 minor one will be how much? The minor one will be equal to what? Will be equal to the confining pressure. Yes, it's very important. Now, from this failure angle, we can find out what? Alpha F. Now, alpha F is how much? 45 plus 5 by 2. Yes. So, once we know this alpha F, I can find what? I can find your 5. I can find your 5. Yes. And you know this relationship. Sigma 1 is equal to sigma 3 tan square alpha F plus 2C tan alpha F. You know your alpha F, you know your sigma 1 and sigma 3, you can find out your cohesion, right? So we can find cohesion and your angle of internal friction by the triaxial test. Everybody understood why we at all conduct a triaxial test. Understood? This is the theoretical and we can say the numerical understanding why at all we conduct a triaxial test. Yes, and this particular thing are known as what? The shear strength. Known as what? The shear strength parameters. They're known as what? Shear strength parameters. Very good. Now, some more understanding from the diagram. Some more understanding from the diagram. You see, this is what? Sigma 1. This is what? Sigma 3. This is what? The shear strength envelope or shear strength equation. This is what? S is equal to sigma n 10 phi plus c. And you can see this is the failure point, right? The failure plane where failure is occurring. This is what? This is your 2 into alpha f, right? 2 into alpha f. Now you see, this is the maximum shear stress, na? Yes, you can see this is the maximum shear stress, na? You see, this is the maximum shear stress in the soil. This is the maximum shear stress in the soil. And you can see this is the failure point. And the stress corresponding to this is what? Is the stress in the failure plane. And you can see that the stress in the failure plane is less than the maximum shear stress, right? It is less than the maximum shear stress. That means soil is not failing at the maximum shear stress. It is failing at a point. Why it is not failing there? I'll make you understand. You see, suppose here, this is the maximum shear stress. Yes, you can see this is the maximum shear stress. At this point, this is the maximum shear strength, stress. But the shear strength is this one, na? Yes. At that particular, you can say that particular normal stress, if this is the maximum shear stress, this is the shear strength, na? And shear strength is more than the maximum shear stress. So will there be any failure? No, because the strength is more. But in this point, what is happening? The shear stress and the shear strength are equal, and therefore failure is occurring. So they can ask this question, right? Now some more points. You see, this is the failure point. This is the failure point. I'll draw the diagram again. You see, this is your, you see, this is your sigma 3, this is your sigma 3, this is your sigma 1, this is your sigma 1. And I told that failure will occur at how much angle? Alpha f. And therefore, here it became what? 2 alpha f. The logic is that whatever angle we see in the real diagram, it becomes 2 times in the Mohr circle. So alpha f and it becomes 2 alpha f. So this is the failure plane. On this failure plane, if I want to find out the shear stress, this will be what? The shear stress on the failure plane. I can find out graphically like this, right? And on this failure plane, if I want to find out the normal stress, this will be what? Normal stress in the failure plane. I'll draw a little bigger one. On this failure plane, there will be a shear stress and a normal stress, which they can ask in the examination, right? This will be the shear stress on the failure plane, and this will be the normal stress in the failure plane. So from the diagram, you can see this is the shear stress in the failure plane, and this will be what? The normal stress in the failure plane, na? Because this plot is between what? The normal stress and the shear stress. Between the normal stress and the shear stress. Now, how to obtain these values? How to obtain these values? I will tell you. Equation, and I will derive also from this particular graph. It is very important. They ask 2 mark questions on the GATE examination. So all of you, please be very alert. Please drink water and be alert. Okay, now you see. This is the radius of the Mohr circle, right? Yes, radius of the Mohr circle. And the radius of the Mohr circle is what? It is sigma 1 minus sigma 3 by 2, na? Yes, the radius of the Mohr circle is this. Yes, the radius of the Mohr circle is this. Now this is the center of the Mohr circle. This is what? Center of the Mohr circle is sigma 1 plus sigma 3 by 2, right? So I can say that from this particular graph, this is suppose O, suppose this is F, and suppose this is A, and suppose this is B. Yes. So can I say that this will be sigma NF right? The normal stress on the failure curve, right? Now this is equal to, can I say this is equal to OA minus OB na? Sorry, OA minus AB na? You see, OA, yes, minus your AB. OA minus AB. Yes. Now, first of all, what is OA? OA is sigma 1 plus sigma 3 by 2. Yes. Yes. Because you see, the center has coordinates of sigma 1 plus sigma 3 by 2. So, OA will be what? Sigma 1 plus sigma 3 by 2. Now, what will be AB? What will be AB? You see this? This rectangle you see. You see this rectangle. Which rectangle? A, B, F. If you see this rectangle ABF, if you see this rectangle AVF, this angle I will draw it here. This is AB, this is R. Can I say this angle will be 180 minus 2 alpha F na? Because you see this is 2 alpha F. So this angle will be how much? 180 minus 2 alpha F. And can I say this AB will be simply R cos 180 minus 2 alpha F. R cos 180 minus 2 alpha F. Yes. And cos 180 minus something is what? Minus cos, na? So they become what? Minus R cos 2 alpha F. The derivation of this, okay? The derivation of this is not important, but it's important to remember. It's important to remember. Yes, we can just mug up, but some logical things are also required. Okay, this is GATE examination. It is not only some memorizing things. We have to be logical also. Right? Very good. So now I can put and write down, right? I can put and write down, right? I can write down now your sigma and F will be equal to, it was OA minus AB. Yes, and this becomes equal to what? This becomes equal to, this was sigma 1 plus sigma 3 by 2 and then minus, what was the AB? AB was minus R cos, minus R. R is what? This one, na? Yes. So this becomes, you see, minus sigma 1 minus sigma 3 by 2. And this comes with a minus, right? Because you see this is minus R cos 2 alpha F. This comes with a minus sign, cos 2 alpha F. We get a plus sign here. So now very important, they ask in GATE examination, they have asked in written times. The normal stress on the failure plane will be how much? Remember this, sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos of 2 alpha F. Now the conclusion is important, but derivation is also important, so I derived it. Now, what about the shear stress? What about the shear stress? So I'll just erase this all. You see, this is the shear stress on the failure plane, na? Yes. So I can say this is the value, right? You see, this is the shear stress, this is the value, right? Now see, this was R, na? Yes. And this is what? The shear stress on failure plane. Yes. And this is what? This is 180 minus 2 alpha F. Can I say from this triangle that you know that the shear stress on the failure plane will be R into sine 180 minus 2 alpha F. You see? R sine 180 minus 2 alpha F. And sine 180 minus something is sine that thing. So this becomes what? Simply R sine 2 alpha F. That is what? Sigma 1 minus sigma 3 by 2 sine 2 alpha F. That's it. Everything we have derived. Now we will solve 12 questions. Now we will solve 12 questions. So everyone is ready now? Everyone is ready for 12 questions. I will solve 12 questions now. Everyone is ready? Please write once in comment section that we are ready, sir. So 1 hour to the lecture. We have completed all the basic theory. I will have some water. Yes. Please write in the comment section. Yes, sir. We are ready to solve now 12 questions. So let's solve them. But before, I'll give you some understanding. What are the tips? First of all, this equation is very important. This equation is very important. So you will be using this equation regularly. Second thing you will use that whenever the equation less soil, then sin phi will be equal to sigma 1 minus sigma 3 by sigma 1 plus sigma 3. Now this is in terms of total stress. Total stress. We can also write in terms of what? Effective stress also. The same equations I will use in terms of effective stress also, right? And what will be difference? This effective stresses will be what? Simply the total stress minus the pore water pressure. This will be what? The total stress minus pore water pressure. So same equations I can use what? In terms of effective stress. Only what will happen? The parameters will change. This will be known as effective parameter, means effective angle of internal friction. This is known as what? Effective cohesion. That's it. Everything remains same. Okay. Now, this equation we derived, the normal stress on the failure plane is what? It is sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2, and then what? Then your cos 2 alpha f, and then your shear stress on the failure plane will be equal to sigma 1 minus sigma 3 by 2 sin 2 alpha. These equations are very important in solving the questions. See, if I, what is numerator? Oh, sorry, numerator, yeah, minus, yeah. So, if I just told the equations and, or started solving the questions without any head and tail, then, you can't get into the group, right? See, so first of all, therefore, I have to explain all the equations. These are the tips. Now, more things. Remember some standard results. Remember what? Some standard results, okay? There are 3 standard results you should remember. What are the standard results? If you are conducting a UU test on a fully saturated clay, then you will get a curve like this, the shear strength curve. You can see here, the shear strength curve is flat. And what is the equation? S is equal to your normal stress into 10 phi plus C. When it is flat means what? It is horizontal means what? That means slope is 0, na? Slope is 0 means what? Your phi is 0. And this intercept will be what? This intercept will be the cohesion. This intercept will be the cohesion. Today's class will be a little long, okay? So all of you please, have some food also. I will not get tired. You will get tired, okay? So please have some food and listen to the class. Okay, I'll complete this shear strength today and then I will end the class. Whatever. It might take 2 o'clock, I will sit. I am not going to end in 30-40 minutes. Okay, I will not end in 30-40 minutes. I have much more energy than 30-40 minutes. Okay, so I will teach till 2 o'clock. If you want to take benefit, please continue the class. Yes. So remember that whenever there is a UU test given and a fully saturated soil, your phi will be 0. And whenever they give a CD or CU test on normally consolidated clay, CD or CU test, very important. Normally consolidated clay, CD or CU test. Now tell me, what is the meaning of this curve? What is the meaning of this curve? What is 0? What is 0 here? Tell me. What is 0? CDCU test. What is 0 here? Tell me. The cohesion is 0 because you see there is no intercept. There is no intercept. It is passing through the origin. So remember that. Even if it is clay, that is the beauty of this particular standard results. Even if it is clay, see for sand it is clay. So for sand the C is 0. For sand, you see, for sand your cohesion is 0. Yes, we know that. But even if it is clay and it is a normally consolidated clay, very important, normally consolidated clay, and you are having a CDCU test, then cohesion will come 0 in that. But if you are conducting on a over-consolidated clay, you will get a curve like this, and you can see here the cohesion is non-zero. Yes? So remember this fact. UU test on saturated clay, UU test on saturated clay, you will get what? You will get phi S0. CD test, CU test, yes, on NC clay, you will get CS0. Remember these standard results. This will be very helpful in solving the questions. Okay. Now answer this question. Very basic, one more question. Answer this question. Then we'll move into the main questions. Moving to the main questions. Very good. NC clay CDCU test gives zero cohesion. Now many students might get confused in this question that how will get zero cohesion in NC clay. That is the standard results we should know. Right? Let us solve questions now. So question number 1 on your way. So question number 1. So students might be thinking, sir, what we were solving? Students might be thinking, sir, what we were solving? Sir is starting question number 1 now after 1 hour 5 minutes. Those questions were warm-up questions. Those questions were what? Warm-up questions, right? In childhood, I used to play Kho-Kho and Kabaddi. You might also have played in your childhood, right? You also might have played in your childhood. So in your childhood, when you used to play Kho-Kho and Kabaddi, the first, our coach sir used to make us, go around the field for, 4-5 rounds. Okay, I used to only do 6 rounds. Sir used to tell 10 rounds. I was little lazy. Yes. So why that 6 rounds? Those 6 rounds are what? Warm-up. So all these questions which we solved are what? Warm-up questions. Everything was warm-up now. So now we are warm-up. Now we'll solve questions. Let us start solving questions. Question number 1. And the question is, in a UU test on fully saturated clay, cell pressure is 60 kPa. Deviatoric stress at failure is 80 kPa. Find the undrained cohesion value. Don't worry, I will solve the questions. Okay, I will solve the questions. You develop the understanding. Now, answer me the questions. UU test on saturated clay, I will get what as 0? UU test on saturated clay, I will get what as 0? UU test on saturated clay, I will get what as 0? Yes, phi as 0. Phi as 0. Very good. Phi as 0. Standard results should be, in your memory. Now, cell pressure is given as 60 kPa. Okay. Deviatoric stress is given as 80 kPa. Very good. Now, pore water pressure is not given. That means I will operate on total stress. I will not go into effective stress. So, sigma 3 will be equal to this. Sigma 1 will be equal to sigma C plus sigma D, that is equal to how much? 140 kPa, and then I will use this relationship. What? Sigma 1 is equal to sigma 3, 10 square 45 plus 5 by 2. So phi is 0, so 10 square 45 plus 2C, 10 45 plus 5 by 2. Phi is 0, so 10 45. Give me the answer. Many students found out the answer also. Very smart, very good. So from this, you see so many concepts we used. First we used that phi is 0 from the standard results. Then we used the concept of sigma 1 and sigma 3, and then we use this equation phi is 0. So this becomes 1. Okay, this also becomes 1. So I can say sigma 1 is your 140 is equal to your 80 plus 2C, sorry 60 plus 2C. So from here what? Your cohesion is 40 kilopascal. Everybody understood how to solve this question. Now these questions looked easy, but you see we use so many concepts. Yes? Let us solve the next question. So question number 2. Very good. Okay. Oh my God, so many things are given. So this question number 2 is actually 4 questions. This question number 2 is actually 4 questions, right? But we'll solve it. Okay, very easy. Okay, okay. So now CD test on normally consolidated clay. Tell me, hello Hasil Khan. So tell me what is 0? CD test on normally consolidated clay. What is 0? CD test on normally consolidated clay. What is 0? What is 0? Yes, C is 0. Very good. C is 0. Right? Now in this question you see minor principal stress is given 250 and then major principal stress is not given. Deviatoric stress is given 275. So this is actually the cell pressure. So from here I can find out the major principal stress. This will be what? The cell pressure plus the deviatoric stress. That is equal to 250 plus 275. That is equal to 525 kilopascal. So I got my sigma 1 and sigma 3. They have asked the angle of internal friction, failure angle with horizontal. Means what? Alpha F. See, if you find alpha F, you can find out phi, right? How to find out? Again use that equation. Again use that equation. Sigma 1 is equal to sigma 3. Yes. 10 square alpha F plus 2C 10 alpha F. Now see, the cohesion is 0 because it is NC clay and CD test. So this becomes 0. Yes. So from here, can I find out what is 10 alpha F? 10 alpha F is equal to sigma 1 by sigma 3 square root. This equation we have already seen na, when C was 0. Yes. Yes. And this is equal to root under, I can say 525 by 250. Give me the answer. What is your alpha F? Give me the answer. What is your alpha F? You see, this is a very simple question. Just I use that C is equal to 0 from the condition what? Your CD test on NC clay. Your CD test on NC clay. Please give me alpha F. Please give me alpha F. Yes, I am getting 55.4 degree. I am getting alpha F as 55.4 degree. Now, if this is the alpha F, can you give me the phi? If this is the alpha F, give me the phi then. Come on. This is the alpha F. Give me the phi then. Give me the phi. This is 45 plus 5 by 2. Very good. Phi. Come on. Very good, Mukul. Very good. Yes. I'll get 20.8 degree. Yes. So you see, by using this simple relationship that C is equal to 0 for CD test on NC clay, and then sigma 1 is equal to sigma 3 plus something, and C became 0. So from this equation anyhow I have derived before, right? I got my alpha F, and once I get my alpha F, I got my phi. See, in examination they will ask one thing only, but I am solving many things, so that it becomes a multi-question. Now the normal stress on failure plane and shear strength of soil. How to find out these two values? Very easy. See, first thing is what? They are asking the normal stress on failure plane. We know the equation, right? Sigma 1 plus sigma 3 by 2. Yes. Plus sigma 1 minus sigma 3 by 2 cos 2 alpha F. You have to remember this equation. I derived this equation. You have to remember this equation. If they ask a straightforward question like this, you can solve so easily, right? If you know the formula. So this will be 525 plus 250 divided by 2 plus 525 minus 250 divided by 2, then cos. Yes, cos how much? I can say 55.4 into 2. So 110.8. Tell me this answer. The normal stress on the failure plane. Tell me the answer. Straightforward question which they can ask in examination. You found out sigma 1, sigma 3 and alpha F and put the values. Please give the answer. Very good. 338.6. 338.7 kilonewton per meter square. So easy question, right? So easy. Now they have asked what? The shear strength. How to find out the shear strength? How to find out the shear strength? One approach is, we know that the shear strength is equal to the shear strength equal to what? The shear stress on the failure plane. Yes, yes, you have derived this thing, yes or no? So this will be equal to what? We have known this equation, sigma 1 minus sigma 3 by 2, then sine 2 alpha f. Yes or no? Yes. So this will be equal to 525 minus 250 divided by 2 into what? Your sine 110.8. How much I'm getting? Tell me. So whenever they ask the shear strength, you can equate to the shear stress at failure. Directly we got 186 and 28.6 I can say. 128.6 I can say. Now this particular thing I can find out in a different way also. If they ask you shear strength, if they ask you shear strength, you can use this equation. You can use another equation also. Okay, very good, Arsenal. Okay, I can use another equation also. What is the equation? You see, this shear strength is equal to what? Normal stress into 10 phi plus C, Yes, and here cohesion is 0. So I can use what? Normal stress. And which normal stress I will use? I will use the normal stress of failure plane, because that only will be the strength, So that is how much I got? 338.7 into 10 phi. Phi also we got 20.8. Yes. So now this also will get how much? 128.6 kilonewton per meter square. Right? So they can ask you and anything. So you can see here, we actually solved how many questions? 4 questions. So if you are following this lecture you can solve almost all the 2-mark questions of shear strength of soil. That is how these particular sessions are designed, yes, by experts, none other than your teacher Satyajeet Sahu. Okay, so hope you enjoyed this particular question. This is not the over. Now I'll explain this question graphically. You see, this was how much? This was the major principal stress, 525, right? This was the minor principal stress, how much? 250. Yes, yes. And I can say the alpha was how much? What was the alpha value? The alpha value was 55.8. So 2 alpha f will be somewhere here, right? You can see, this is the center. 2 alpha will be 110.8. You can see here. Yes. This is 2 alpha f is equal to 110.8. And I will get the shear strength line, or I can say the particular thing like this, right? You see. And therefore you see the cohesion is 0. You see the cohesion is 0, right? And this is the failure plane. And you can see that this is the normal stress on failure plane, which we got how much? 338.7. You see, this is between 250 and 525, right? Yes. And you can see that this is the shear strength is equal to the shear stress on the failure plane. And this we got how much? This we got how much? This we got 128.6. Now if I ask you the maximum shear stress, the maximum shear stress is how much? The maximum shear stress will be the sigma 1 minus your sigma 3 divided by 2, giving me how much? If you find this answer, how much you getting this? 525 minus 250 divided by 2, giving me how much? 137.5. You can see the maximum stress is more, but the failure is occurring at a lower stage. See how beautifully we have understood 4 questions in one question and understood the diagram graphically also. And you see, this is phi, and this phi is looking how much? 20.8, Has anyone taught you like this? The answer is no. Let us go to the next question. That is what? Question number 3. So more 10 to come. Okay. Let us solve this question. Okay, they have asked you the effective angle of internal friction. Whenever they ask you the effective angle of internal friction, that means what? That means there is pore water pressure. There is pore water pressure. Again, it is given what? CU test on normally consolidated clay. What is the meaning of this? What is the meaning of this? CU test on normally consolidated clay. Please write in the comment section. What is the meaning of this? CU test on normally consolidated clay. What is the meaning of this? What is the meaning of this? CU test on normally consolidated clay. C is 0. Very good. Very good. The cell pressure is given as 100, right? The deviatoric stress is given as 80. So from here, I'll get sigma 1 is equal to 180, sigma C plus sigma D, and sigma 3 will be equal to 100 kilopascal. But they have asked the effective angle of internal friction. So I'll find out the effective stresses. The effective measure stress will be how much? 180 minus the pore water pressure, giving me how much? 130. And then this particular thing, sigma 3 will be how much? Will be 100 minus the pore water pressure, giving me how much? Giving me 50. Now give me the angle of internal friction. Let us see. Effective angle of internal friction. How many will solve this? Fatapat. Fatapat. One hint, cohesion is 0. Cohesion is 0. Cohesion is 0. Cohesion is 0. Come on, which equation I will use? And solve and give me the answer. Solve and give me the answer. Come on, come on, come on. Okay, 26.4, Karthike, very good, Vivek, very good, Vivek. I'll use this relationship, right? Sin phi dash will be equal to sigma 1 dash minus sigma 3 dash by sigma 1 dash plus sigma 3 dash. Why I'll use? See, this equation I can use for sand and whenever C is 0. Not only for sand, whenever C is 0. And C is 0 for your CU test when you're using NC clay. So you see how fast you're able to solve this 2-mark question by having this understanding. 51 watching, very good. One day 100 people will watch and then 1000. One day will come. Okay. Remember people, I have told once, yes, that students will increase. They are increasing. As the gate approach, people will increase. Now 50, 100, 150, 200. Let us see who will stop us. So this is how much? 130 minus 50 divided by 130 plus 50. Tell me, what is the answer here? Oh, you got the answer. Very good. You got the answer. Phi dash is equal to 26.4 degree. Okay. But at the same time, we have to be humble. We have to be focused on the examination. We should not be carried away by this much watching, that much watching. In the examination, we have to be serious. So let us come back. Okay. Now, the next question. The next question is question number 4. Yes, question number 4. Okay. How to solve this question? It's a small question, but a tricky one. It's a small question, but a tricky one. It is written the failure angle makes 35 degree with the minor principal plane. A tricky one. Let me solve this for you. You see, this is the failure plane, right? You know, this is the failure plane, right? This is the failure plane, right? And this is what? The major principal plane, right? This is what? The major principal plane, because the sigma 1 is acting. And with the major principal plane, it is making alpha F angle, right? It is making alpha F angle. But in the question, it is given what? With the minor principal plane. This is the minor principal plane, na? This is the minor principal plane, na? Why? Because sigma 3 is acting on this. So this is the minor principal plane. Now see, if the failure plane is making alpha F with the major, with the minor it is making how much, tell me? With the minor it is making what? How much angle, tell me? From the diagram, if it is making alpha F with the major principal plane, with the minor principal plane, it is making how much angle? Yes, it is making how much angle, tell me? Oh, some people have found out the answer also. Tell me, what is this angle, tell me? This will be 90 minus alpha F. Yes, this will be 90 minus alpha F. You see this triangle? So this is alpha, so this will be this angle and this angle will be same, na? So 90 minus alpha. So that means this angle 35 degree given is what? This 35 degree is 90 minus alpha. So from here alpha f is how much? It is 55 degree, and this is equal to 45 plus 5 by 2. Yes. And from here phi is equal to 20 degree. You can see it's a tricky question, right? It's a tricky question, not a direct question. Yes. So now understand, this alpha f is between what and what? It is between the failure plane and the major principal plane, or I can say what? Horizontal. Yes. But with the minor or the vertical, this particular failure planes makes how much? 90 minus alpha f. So read the question carefully. Thank you very much. Let us go to the next question. Question number 5. You can see that our speed of solving questions has increased, right? Our speed of solving questions has increased. Okay. Now see this question. A drained triaxial compression test on a saturated clay yielded the effective shear strength parameters as 15 kilopascal, and this is not 220, no, this is 22 degree. It's 22 degree, right? So consolidated undrained test on the identical sample. See, when you do the test on the identical sample, then in this test also the earlier parameters can be used because the same soil, right? At a cell pressure of 200 kilopascal, cell pressure is given 200 kilopascal, right? And your pore water pressure is given how much? Pore water pressure is given how much? U is given how much? 150 kilopascal. So pore water pressure is given high because we are dealing with what? We are dealing with the effective strength parameters, right? Yes. So now from this, sigma 3 is how much? Sigma 3 is 200. Sigma 3 is 200, right? And then your sigma 3 dash, the effective minor stress, will be how much? 200 minus pore water pressure, giving me how much? 50 kilopascal. Giving me how much? 50 kilopascal. From this, can you find out this value? Sigma 1 dash, yes, I can use the relation. Sigma 3 dash 10 square 45 plus 5 dash divided by 2. Why 5 dash? Because I am using the effective stress parameters. Plus 2c 10 45 plus 5 dash divided by 2. It's a very straightforward question. The phi and c are given to us. Okay, sigma 3 dash we got as 50. Can you find out the major principal stress? The effective major principal stress? Okay, BBEC found out the answer also. So 5 dash is given how much? 22 degree, and it is given 15. Okay, so put here 15, and this will be, 22 by 2. So 11, so 56. Yes, this will be 22 by 2, 56. Can you give me sigma 1 dash? Give me sigma 1 dash. I can say it will be 50, 10 square 56 plus 30, 10, 56. Yes, so how much I am getting? How much I am getting? 100. Now tell me sigma 1 dash. Don't give me the final answer. Give me 101 dash. Sigma 1 dash. What is sigma 1 dash? Tell me. Come on, 154.4. Very good. Again, I will repeat the question. In the question, they have given phi and c dash. In the question, they have given phi and c dash, right? Now they have given sigma 3 because cell pressure is sigma 3. They have given the pore water pressure. So I can find out sigma 3 dash, the minor effective principal stress. So from that I found out what? Sigma 1 dash. Now what is deviatoric stress? Deviatoric stress is major minus minor, na? Yes. Because if you remember, sigma 1 is equal to sigma c plus sigma d. Yes. So from here, sigma d will be equal to sigma 1 minus sigma c, and sigma 3 is nothing but sigma 3, right? So I can use in terms of effective also. So very easy. So 154.4 minus what? Your 50 giving me how much? 104.4. You can see that this question is actually very easy. You can see that this question is actually very easy, right? They gave C, they gave this, and very simple question, right? Let us solve another question. The question number 6. Now in this question you see a diagram is given. They're asking you B. Okay, in this diagram, just name me some things. What is this 120? What is this 120 in the diagram? What is this 120 in the diagram? Tell me. What is this 120 in the diagram? Yes, this is sigma 1 and this is sigma 3 and this is 2 alpha f, right? Because this is the failure plane. So I can say your alpha f will be equal to 56 degree. Yes, alpha f equal to 56 degree. They have asked you find out this B. Find out this B. What is this B? Tell me. What is this B? Tell me. Now see, many students who were not able to understand many things. Now it can be effective also. Deviatoric can be effective also. You see, deviatoric will be equal to sigma 1 minus sigma 3. It can be equal to what? It can be equal to this minus this. Why? Just I will give you a small idea. You see, this is what? What is sigma 1 dash? It is sigma 1 minus u, this na? Yes. And this is what? Sigma 3 minus this, right? Now if you open the bracket, sigma 1 minus u minus sigma 3 plus u. So plus u minus u get cancelled. So you write down this or this, doesn't matter. It is same thing. Very good. Now, what is B? Tell me. What is B? Yes. Very good, Tejoram. Very good, Nikki. Others. What is this B? This is sigma NF, the normal stress on the failure plane. Very good. This is the normal stress on the failure plane. Yes. Normal stress on the failure plane. You know the equation, right? Sigma 1 plus sigma 3 by 2, yes, plus sigma 1 minus sigma 3 by 2 cos 2 alpha f. You see, by knowing the diagram, if I ask a question for the diagram also, you can solve the questions now. That is how you become expert in solving questions of GATE. You have to develop deep understanding of the concepts and numerical solving abilities. So if you want to develop such, numerical solving abilities, please continue attending the lectures. So please find out the answer and tell me. Very good. Almost we're getting 65. I'm not solving for you. I'm not solving for you. Okay, 65.1 kilopascal. Sigma 1 is given from the diagram we guessed. From sigma 3 is given, and this is, we know, this is the failure point, failure plane, right? It makes 2 alpha f. So from there I got my alpha f. Everybody understood how to solve this question? You see, this can be a 2-mark question in the GATE and you solved it nicely. Let's go next question. Question number 7. So we are halfway. We are halfway. 6 questions are over. More 6 to go. Okay. Okay. Yay. Okay. Now here you see, it is given that a CU test is conducted on a saturated sand. Okay. Saturated sand. You see, at a cell pressure of 80 kilopascal. The deviatoric stress was 270 kilopascal. Yes. And the pore water pressure is given how much? 50 kilopascal. Find out the effective angle of internal friction. Please solve this question. I have given you enough hints. Please solve this question. I will take some rest now. Please solve this question. Let us see, are you able to solve this question yourself or not? Please solve this question for me. Rakesh Rosen is answering 43.14. 43.14. Others? Others also? Hey, why you are taking so much time to solve this question? Huh? Sigma C is 80. Sigma D is 270. Sigma 1 is 350. Sigma 3 is 80. Okay. It is given negative. Oh my God, many answers I got. See, the pore water pressure is given negative. U is equal to minus 50. कैसा लगा मेरा मजाक? Okay, Arsenal, solved it correctly. Very good. It is given negative. So, sigma 1 dash will be how much? 400, and sigma 3 dash will be how much? 130. It is given sand. So, C is 0. Yes. I can directly use sine phi dash is equal to sigma 1 dash minus sigma 3 dash by sigma 1 dash plus sigma 3 dash. This is 270 by 530. You will get phi dash is equal to 30.63. Again, you see, this question is not lengthy. Okay. So this will be the type of questions in the GATE examination. They won't be lengthy. The questions in the GATE examination won't be lengthy. They will be tricky like this, conceptual. Okay, very good. So question number 7 is over. Let us go to the next type of test, unconfined compression test. Let us go to the next type of test, that is what? Unconfined compression test. Now, unconfined compression test is a special triaxial test. What is so special about it? What is so special about it? It is unconfined. It is unconfined under undrained conditions. Unconfined means what? The confining pressure is 0. The confining pressure is 0. If the confining pressure is 0, can I say that the minor principal stress will be 0, right? So this is a special case of triaxial test where the confining pressure is 0 or the minor principal stress is 0 in this case, right? So I'll get such a diagram, right? You see, this will be sigma 1 and this will be sigma 3, right? This will be sigma 1, this will be sigma 3. Now see, confining pressure is 0 means what? Initially in the consolidation stage, there will be no all-round pressure, right? Only the deviatoric stress will come into picture, right? Only the deviatoric stress will come into picture, right? Only the deviatoric stress will come in picture. And I can say this deviatoric stress will be sigma 1 here because in unconfined compression test, the sigma C is 0. Sigma C is 0, right? Understood? And this also will be known as QU because you're applying this vertical load and then what is happening? There is failure like this, right? At alpha F angle, right? There is failure like this. So this QU is also known as what? This QU is also known as what? Unconfined. Why unconfined? Because the confining pressure is 0. Unconfined compressive strength. Understood why it is known as unconfined compressive strength? Because there is no confining pressure. We are applying compression load, right? And this is the unconfined compressive strength. So very beautiful concept that in case of unconfined compression test, the major principal stress will be equal to the unconfined compressive strength. That will be equal to what? The deviatoric stress. Understood from the diagram? Yes. Now you see. Here, since you can say that this is the more circle, I'll get the failure envelope like this, right? In this, I can say the phi will be 0 if you are conducting the test on clay. If you are conducting the test on clay only, then the phi will be 0. I will elaborate this point later. I'll elaborate this point later. Is my sound audible? Is the sound audible to you? Is the sound audible to you? I am speaking a little lower volume now. Yeah, that's very good. You see, if you are conducting this test on in a clay, then you get phi 0, right? You see now. Now see, if you are conducting this test on clay, then I'll get a phi 0 means what? A flat line, right? And this will be the intercept. So this will be what? This will be cohesion, and this will be the CU. CU means what? Undrained cohesion. Undrained cohesion. Why I'm calling undrained cohesion? Because I'm conducting the test under undrained conditions. Okay, now you see. This CU is equal to this one, right? You can see. This U is equal to this one, right? CU. Yes. And this is also, the failure is occurring here, right? Failure occurring here. So this is also the shear stress. This is also what? The shear stress on the failure plane. This is also the shear strength, right? And this is undrained condition, so I can say what? This is the undrained shear strength. Okay? Undrained shear strength, right? From the diagram we can understand many things. You can see from the diagram also I can understand many things. Yes. Now you see, this will be the radius, na? This will be equal to the radius of this particular Mohr circle, right? Yes. Now radius of a Mohr circle is what? Sigma 1 minus sigma 3 by 2. Here sigma 3 is 0, so only what? Sigma 1 by 2. And what is sigma 1? Sigma 1 is QU, right? So we get another important relation, this particular relation. Yes, this particular relation. So I can summarize that if you are conducting an unconfined compression test on clay, then this particular sigma 1 will be equal to deviatoric stress equal to the unconfined compressive strength, right? At which the failure is occurring like this at alpha F angle, right? And if you are conducting on clay, then I will get a failure curve like this, and in this condition I will get these conclusions. What are the conclusions I will get? That the undrained cohesion will be equal to the undrained shear strength equal to what? The unconfined compressive strength divided by 2. This is what? The unconfined compressive strength. This is your unconfined compressive strength, right? This is your undrained cohesion, right? And this is what? The undrained shear strength. This is what? The undrained shear strength. Very good, students. Yes, but this is applicable only when you're conducting unconfined compression test on clay, because in clay only the phi will be 0. In clay only phi will be 0. I can apply these rules there only, right? Now in unconfined test, you see actually how to get that QU. How to get that Q? Very easy. This QU will be equal to, you'll apply some load P, suppose you'll apply some load, right, P, and your QU is a stress. Unconfined compression strength is a stress. So stress will be what? Stress will be load by area. Load by area. Now you see when it will fail like this now, you see. It will fail like this now. Yes. That means the area would have changed at failure. So I'll use the area at failure. Now how to find out the area and failure? The area and failure will be the original area by 1 minus the axial strain. 1 minus the axial strain. Okay. Now how to find out this axial strain? See, at the failure, this sample has deformed by what? Delta, na? Right? Deformed by delta. And this is the original length of the sample, L. So this axial strain will be what? It will be your delta by L. Yes. The original area will be knowing. Yes. the original area you will be knowing, and what you will do, this original area divided by 1 minus the axial strain will give me the final area. Yes, and the load divided by this will get me the QU. Understood how I am getting the QU, unconfined compressive strength? From this they will ask a question. We'll solve, don't worry. We'll solve a grand question. Don't worry. Okay. Now, solve this basic question first. Solve this basic question, then we'll solve a bigger question. Oh, very good. You see, unconfined compression test, the undrained shear strength is given 35 kilopascal. That means what? SU is given. From here you can find out what? The undrained cohesion, that is equal to how much? It will be same as that of the undrained shear strength, that is how much? 35 kilopascal. Now tell me, if the question was, find unconfined compressive strength, what will be the answer? What will the answer, tell me? Very good. It will be QU, that will be twice of the undrained cohesion, that is equal to 70 kilopascal. Now this is a basic question. No, this lecture will be available after the video also. But still I will request that please attend the lecture live. Yes. Okay. Now solve this question. Which of the following condition, MSQ, which of the following condition is or are true about unconfined compression test? Please see which MSQ, so which of the answers is correct? A, B, C. Very good. Very good. You see, in an unconfined compression test, cell pressure is 0. Cell pressure is 0 means your minor principal stress is also 0. And we have seen that the major principal stress becomes equal to what? The deviatoric stress. But the undrained cohesion is not 0. Undrained cohesion is not 0. Yes, the cohesion is non-zero. So you can see that such kind of complicated questions also you are able to solve if you have developed the correct understanding. If you have developed the correct understanding, yes, instead of solving random questions from random sources, many people do that. I don't recommend. I recommend first study the topic properly and then solve questions like we did today, right? Okay, question number 8. Okay, so we have a saturated clay. Yes, 50 mm in diameter. So it's a cylindrical sample and 100 mm in height. So we have a sample, cylindrical sample. Okay. So in this question we'll solve many things. Cylindrical sample. This is 100 mm. Okay. And the diameter is given 50 mm. Diameter is given 50 mm. Yes. Undergoes unconfined compression under axial load of 150. So this is the failure load P. The axial deformation is given at failure, means what? This delta is given. And this will be the length of sample, right? So first question is to find out the unconfined compression test, compressive test strength, QU. How to find out QU? That will be equal to your load by final area. Now I have to find out the final area, right? How I'll find the final area? The final area will be equal to the initial area by 1 minus axial strain. Now what is the initial area? The initial area will be how much? Pi by 4, suppose I am expressing everything in meter, suppose I'll express in meter. So 0.05, right? Because 50 mm will be how much? Your meter, right? Why I'm expressing in meter? So that I can get the stress in kilonewton per meter square. Kilopascal means what? Kilonewton per meter square. So I'll convert everything into kilonewton and meter. Okay. So this square divided by 1 minus axial strain. What will be axial strain? Axial strain will be the deformation 10 mm by the length. 0.1, right? Yes. Axial strain will be how much? Deformation by the length. So how much? This is 0.1. So how much you are getting this final area? Tell me. This final area how much I am getting. And this axial load is 150 Newton. I'll convert into kilonewton. So I'll convert it to kilonewton. So load is converted to kilonewton. Area I got the final area. How much I am getting? Tell me final area. And from that give me the QU. From that give me the QU. .75. No, area. Give me the area, man. I told you area. Don't give me the answer. I first asked you area. Very good. 0.00218. So now the answer QU is how much? It is 68.76. 68.76 kilonewton per meter square. Everybody understood in an unconfined compression test how to find out QU. Yes, many people don't know. How many people understood this first time in their lives? How many people understood this thing first time in their lives? I think many also know, but still you understood this nicely. So they might not give you QU. You have to find QU like this, right? Now the second question is undrained cohesion. That will be half, na? Undrained cohesion will be half, na? Yes. So how much? So in this, first of all, we got the QU. That is equal to 68.76, right? And the CU is half of this, QU by 2. That will be equal to 34.38. This will also be the shear strength, right? Undrained shear strength, right? So in this question, if they ask you cohesion, the undrained cohesion, first of all, you have to find out QU divided by 2. And this will get how? The failure load divided by the final area. And this final area is what? The initial area by 1 minus axial strain. So very standard question which GATE can ask. It's a very standard question which GATE can ask in the examination, right? Now, many students think, so this is the diagram. This is how much? This we got as 68.8 and this we get as what? 0, sigma 3 is 0, this sigma 1, okay? And then this is the failure envelope I will get, right? Right? And this is the cohesion, undrained cohesion, that is equal to the shear strength, that is equal to the QU by 2, giving me how much? 34.4. If in this question I ask you what is the deviatoric stress, then what will be the answer? What is the deviatoric stress here? Tell me. If I ask you deviatoric stress, what will be the answer? Deviatoric stress. What is the answer if I ask you deviatoric stress? If I ask you deviatoric stress, what is the answer? Yes, it will be equal to QU, that is equal to the major principal stress, that is equal to 68.8 kilopascal. Very good. Okay. So this was your question number 8. So 4 more questions to go. Question number 9. Okay, question number 9. You see here it is given. Okay, here it is given. Okay, before that, some more understanding. Some more understanding. Okay. Now, in an unconfined compression test, if I am conducting on pure clay, pure clay means what? Phi is equal to 0, na? Phi is equal to 0, na? Pure clay means what? Phi is equal to 0. Yes. So phi is equal to 0. So if phi is equal to 0, alpha F will be how much? Tell me. What will be the alpha F if we are conducting this unconfined compression test on a soil sample? What will be alpha F? Tell me. If yes, it will be 45 degree. Yes, the failure plane will be 45 degree. The failure plane will be 45 degree. Yes, and this will be your alpha F because the phi is 0. Now, if in the question it is given alpha F is not 45, it is given not 45, that means what? It is not a pure clay, na? Yes, it is not a pure clay. That means what? The phi is non-zero there. The phi is non-zero there. That means what will happen, tell me? What will happen? If I see this diagram, everybody understood this concept? If phi is 0, pure clay, that means what? This alpha will be obviously 45 plus 5 by 2, so 45. But if the alpha is not 45, it is suppose 48 or 51 or 53, whatever, it's not a pure clay. Means what? Alpha is not 0. So in that case, this particular diagram, yes, this will be sigma 1 is equal to QU, is equal to deviatoric stress, no doubt about that. This will be 0, but the failure envelope will be something like this. This concept many students don't know, that unconfined test always the phi is not 0. In an unconfined compression test, how many people understood this concept first time in your life, that in an unconfined compression test always your phi is not 0. Sometimes it is 0 in case of what? Your pure clay. Then in that case I will get a flat line. But if it is not a pure clay, then what? I will get what? C5 soil, right? C5 clay. Yes, I'll get an inclined. Means what? There will be some what? There will be some angle phi. Yes. And now tell me, ladies and gentlemen, now tell me, in this particular condition, in unconfined compression test, if I'm having phi not equal to 0, can I write that Cu is equal to, can I write Cu is equal to Qu by 2? Can I write now? Tell me, can I write this thing or not? Tell me yes or no. Can I write this thing or not if it is not a pure clay? No, I can't write. Because you see, this is your cohesion, right? This is your cohesion and this is your Qu by 2, right? You see? This is your cohesion and this is Qu by 2. I can't write. Yes? So I can say this Cu is equal to Qu by 2 is applicable for pure clay, and this will not be equal to Qu by 2 if it is a C5 soil. Means what? Your phi is non-zero. And how you will judge that? Tell me. That the phi is 0 or not, how you will judge? Tell me. Phi is 0 or not, how you will judge? I have told. How you will judge that phi is not 0? Please tell me. How you will judge that phi is not 0? I just told the method. How you will judge that phi is not 0? Come on, tell. Yes, tell. How you will judge that phi is not 0? Arey Baba, I told na. Writing. Slope, more things. If the failure angle is not 45 degree, very good Kartike. If the failure angle is not 45 degree, it is not a pure clay. If it is 45 degree, yes, it's a pure clay. Understood? Pure clay, phi will be 0. I can write down Cu is equal to Qu by 2. Yes. See, you have written it is not pure or something. But how you will judge? You are engineer, na? You will not see and judge, na? You will conduct some experiment, right? So in the unconfined compression test, if the failure angle is coming 45 degree, it's a pure clay. And you can write this condition. And if the failure angle is not 45 degree, that means what? It is not pure clay. Phi is non-zero. You cannot write Cu is equal to Q by 2. Understood this concept or not? Beautiful concept, right? Yes? Beautiful concept. And many of you might be feeling like engineers now. Oh, we are engineers, man. We forgot. We forgot. We have become, what we have become, we don't know. But many of you might have felt like engineers by understanding these kind of concepts, right? Yes, it's a very beautiful concept. Many people don't teach this because they don't know this. Okay, but I know, so I taught. So first of all, ladies and gentlemen, first of all, how to judge? Now you will answer me. You will answer me. You will answer me. How to judge it is pure clay or not? You will answer me. How to judge it's a pure clay or not? How to judge the pure clay or not? Yes, if your alpha F is 45 degree, yes, then phi is 0, pure clay, Cu will be equal to Qu by 2. And if alpha is not equal to 45 degree, then it's a C phi soil. That means clay, it's a C phi clay. Some value of phi is there. So phi is not 0 and Cu will be equal to not equal to Qu by 2. Very good, very good. Not equal to Qu by 2. Nothing is given in the question. What you will assume? So failure angle is not given in the question. What you will do? Failure angle is not given in the question. What you will do? Failure angle is not given in the question. What you will do? You will assume that it's a pure clay. Okay? If failure angle, okay? If failure angle is not given in the question, then assume what? Assume pure clay. Assume pure clay. Otherwise, so as you see in this question, in the first question you see, in the first question which we solved, you see it is written only saturated clay and nothing is mentioned about what? The failure angle. So in an unconfined compression test, if they mention nothing about the failure angle, what you do? Just assume pure clay. But in the next question you see, in this ninth question, the failure plane makes 50 degree with the horizontal. Yes. The failure plane makes 50 degree with the horizontal. Yes. So that means it's not a pure clay. So first of all, give me phi value. First of all, give me the phi value. First of all, give me the phi value. First of all, give me the phi value. What is happened? Police. Okay, emergency call. Sorry, they're telling Bangalore police will come. No, no, no. Phi is equal to 10 degree. Very good. Yes, because alpha F is given 50. This is 45 plus 5 by 2. Now, the way we find out unconfined compression strength, Qu will remain same. So Qu we can find out the same manner. What? Qu will be equal to the failure load by the final area. And final area will be how much? The initial area by 1 minus axial strain. So data is given. Give me the Q. Everything is given. Convert everything into kilonewton and meter. So this is diameter is 4 centimeter. I can write down 0.04 meter. Okay. The height is 8 centimeter. Okay. And 8 centimeter I can write down 80 mm. Axial deformation is 8 mm. This is the load. So I can say the axial strain is 80 by 8 by 80. That is again 0.1 only. Okay. So give me the Qu. Chalo. Give me the Qu. First to find out the final area. Okay. Find out the load is given. 360 kilonewton. So I'll convert in kilonewton. Final area I can get. Initial area is how much? Pi by 4 into 0.04 square divided by 1 minus the axial strain. This will give me the final area. Okay. Use this and give me this, Final answer. Give me the QU. 257.96. Yes, I can almost take 258, right? I can almost take 258 kilopascal. Almost take 258 kilopascal, right? So till finding QU, it is easy. If it is not a pure clay, till finding QU, it's easy. It's not a tough thing, okay, to find out QU. Now what happens next is how to find out the CU, because CU is equal to QU by 2. I cannot write this here, I cannot write this here. Yes, I cannot write this here. Yes, I cannot write this here because it is not a pure clay. I cannot write this here. So how to find out CU in such cases? I'll explain it from the diagram. I'll explain diagram, you see. This is what? This I got is the sigma 1, that is equal to deviatoric stress, that is equal to the QU. How much this is? 258 kilopascal I got. Now, you see, alpha F I have got how much? Alpha F I got is 50 degree, So, the failure plane will be somewhere here, 100 degree, you see. To alpha F. You see, diagrams are so important. 100 degree, right? And this will be the failure plane. Now, you see, first of all, this CU will be equal to the shear strength, right? It will be equal to the sorry, I just, what to do in this case. Yeah, I can do this thing. Okay, Arsenal found out the answer also. Smart boy, found out more before me. See, this will be your failure fan stress and this will be your SCU, right? The shear strength, right? Shear strength. Now can you give me the shear strength that is equal to the stress on the failure plane? That was how much? Sigma 1 minus sigma 3 by 2 sine 2 alpha F. Okay? This question is never asked in exam, but it will be asked in the next time. So you see sigma 3 is 0, sigma 1 we got, and alpha F we know. Now tell me what is this shear stress on the failure plane? That is equal to the shear strength. Give me this. Give me this. This is a little tough question, but I will solve it, don't worry. Arey, put the values. 258 by 2 sine 100. I will solve. You are not solving. 258 divided by 2, okay, into sine 100. Sine 100. I am getting 127, right? What are other students doing? Why they are not commenting? 127, very good. This we got the shear strength. This we got the shear strength, right? Now, can you give me this normal stress on failure plane? Yes, that formula also we know. The normal stress on failure plane will be equal to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 into what? Cos 2 alpha F, right? And sigma 3 is anyhow 0. Sigma 3 is anyhow 0. I can take sigma 1 by 2 common, right? So I can take sigma 1 by 2 common and then 1 plus cos 2 alpha F. Give me the value of this. Okay, this will be 258 divided by 2, then 1 plus cos 100. How much I am getting? This. I am getting 106.6. 106.6. Okay, 106.6. Your answer is not wrong. We'll see. Don't worry. Okay. So first of all, what I did First of all, what I did, I found out the shear strength. Shear strength is the stress in the failure envelope or failure point, right? And this is the normal stress on the failure point. Now, shear strength is what? Shear strength is equal to sigma n failure plane 10 phi plus Cu. Yes, this is the equation, right? Shear strength is equal to sigma n 10 phi plus Cu. And we have already found out phi. So now from here, can you give me the Cu? Yes, I can find out the Cu now. So Cu will be equal to this Su, how much I got? Su, how much I got? 127, right? 127 minus sigma nf 106.6 and then 10 phi. Phi is 10 degree. How much I got Cu, tell me? I'll explain at the end, don't worry. $108.2. Okay, so here we used all the equations. So this is the way you find out Cu. Okay, Arsenal is saying I found sigma 1 is equal to 2C10 alpha. Sigma 1 is equal to 2C. Sigma 3 is 0. Okay, that way also we can find out, right? That way also we can find out, right? You see, sigma 1 is equal to sigma 3. Sigma 3 is 0. Directly 2Cu. Oh, that was cool. Yes, that is good. So I was taking longer approach. Thank you very much, Arsenal, for teaching me a shorter approach. Okay. So here also we can solve like this. That was cool. You see, this is what makes a teacher happy, that when the student understands and then become more. So I always tell that, that Sachin coach never played for India, but he made a Sachin, right? So coaches are different, right? So thank you very much, Arsenal, for, such wonderful solving. Yes, sigma 3 is 0, so that terms goes away. So sigma 1 is how much? 100. We got how much? Sigma 1, how much we got? The deviatoric stress, how much we got? We got 258. Yes, so 258 is equal to 2 into Cu 1050. Oh, that was cool. So from here also I can find out 129 by 1050. I'm getting the same answer. 129 divided by 1050. Oh, great. 108.2. Great. So I'll summarize now. I'll summarize this unconfined compression test. Okay. I'll summarize this unconfined compression test. So if the failure angle is given 45 degree or nothing is given, then assume this. In this case, the failure envelope I will get like this. And in this case, I can say your Cu will be equal to Su is equal to what? Qu by 2. But if it is not given, okay, like in this case, it was given how much? It was given 50 degree. That means what? It is, the phi is not 0. Here the phi is coming 10 degree. And in this case, you can see we got this as how much? 258, right? And the failure point we got here, this is your 2 alpha f 100 degree. And you can easily see that, see, this cohesion we got how much, tell me? This cohesion we got how much? This cohesion we got value how much? 120, so 108.2, right? 108.2. Whereas you see Qu by 2 is how much? Whereas Qu by 2 is how much? 129. You can see that your Cu is equal to 108.2 is not equal to Qu by 2. And by the way, the shear strength how much we got? This is the shear strength, right? The shear strength how much we got? Value? The shear strength value we got how much? 100, how much? 106.6, right? or 100 something? How much I got? Please tell in the comment section, because I don't have the calculations. You are calculating. How much we got the shear strength? 127. Yes, 127 kilopascal. And you can see that your Q by 2 is this one, na? You see? Your Q by 2 is this one, na? You see? So Q by 2 is 129, but SU is less than that is 127, and CU is 108.2. And you can see that in this case, the CU is not equal to SU, not equal to QU by 2. If they ask you anything, now you can solve all the questions of unconfined compression test. Yes or no? Now you can solve all the questions of unconfined compression test. Anything they ask, let them ask anything, you can solve, right? It is on pure clay, on not pure clay, okay? Everything you can answer. Now let us go to the Vane shear test. Vane shear test is a very easy test, okay? We enter this inside the soil sample and we apply the torque. The torque at which the soil sample fails. From this I can find out the undrained shear. The undrained shear strength, okay? The undrained shear strength directly we found out, okay? You have to remember this formula. The undrained shear strength will be equal to T by pi d square, then d by 6 plus h by 2. D by 6 plus h by 2. Very good. So now solve a very easy question. Like you see this question in a Vane shear test. See, Vane shear test is the easy one. Okay. Vane shear test is the easy one. See, the tough ones were the Triaxial test, right? The tough ones were the Triaxial test. So hope you have covered that, right? I covered the Triaxial test and the unconfined compression test in details. Yes, I covered the unconfined compression test and the Triaxial test in details. Yes, because that is a tough one. Vane shear is very easy. Now, Vane shear is very easy. So from directly I can use, you see, the shear strength will be equal to the torque divided by pi d square, then d by 6 plus h by 2. What are these d and h? We'll see this in this equation. Okay, in this polar diagram. You see, this is the Vane. Okay, it will rotate. You can see this is the diameter of that particular Vane. Yes, because if you see from top, it will look like this, na? You see, from top it will look like this. From top it will look like this. So this will be like this. Yes, so it's like a circle kind of thing. Rotate, na? Circle kind of thing. So this is the diameter. Yes, and this is the height of the Vane. This is the height of the Vane. Okay. So very simple question we will solve here. Simple question we will solve here, right? So this will be equal to the if you want to find out the answer in what? If you want to find the answer in kilonewton per meter square. So everything I'll express in kilonewton and meter. You see, the torque is given 100 Newton meter. So 100 Newton meter is what? 100 into the power minus 3 kilonewton meter, right? Divided by your pi. D is how much? It is given 100 mm. That is how much? I can say 0.1 meter. And this is 200 mm. That is what? 0.2 meter H. So it will be 0.1 square, then 0.1 by 6 plus 0.2 by 2. What is the answer getting? Very good. It's a very straightforward thing you should know. It's a very straightforward thing you should know. Yes. Yes. Understood? So Vane shear test is not a big deal. The big deal was Triaxial and unconfined compression test, and I completed that in details. Thank you very much. This is the end of the lecture. So we have two homeworks now. We have two homework. Okay. So I'll give you lot of homeworks. Okay. I'll give you lot of homeworks. So two homeworks. So first homework is you have to study this pore water pressure parameters. How to study? I'll give you what to do. You visit the BYJU'S Exam Prep app. Okay, you go to what? App. BYJU'S Exam Prep app. In that, you go to what? Video lessons. You go to what? video lessons. Yes, in that you go to which subject? Geotech. Okay, learn with video lessons. The section is there. Learn with video lessons. Okay, this is available only on app. Okay, so there you go to Geotechnical. In Geotechnical you go to what? Shear strength. Okay, you go to what? Shear strength of soil, right? In that you will find a video, what? Pore water pressure parameters. Please study that topic. It is hardly 20 minutes topic. Okay, so this is your homework. First homework, study this topic. Okay, so I'll give you many homework. Okay, many homework, and homework makes us good. Okay, so then you study those topic, and then question number 11, this question I have solved in that particular video. Okay, and question number 12, I have also solved this question in that particular video. These two questions based on the pore water parameters A and B, I have taught in that particular video. So please go to that video. That video is freely available for everyone. Okay, so please go to that video and then see that video. Okay, and solve these two questions. These two questions are solved in that particular video. Okay, please do it, please don't delay. And then comes what? Homework questions. Then comes what? Homework questions. Question number 1. And homework questions are not from the pore water pressure parameters. They are from what? Triaxial test and unconfined compression test. So question number 1 is the homework. Question number 2 is the homework. Question number 3 is the homework. And question number 4 is the homework. All these questions, okay, have certain video limits, because you see there has to be a limit. Everything cannot be free, right? Everything will not be free, because after you do job, you also will not serve for free. So everything is not for free. So if there is some limitations, that is put, because everything cannot be given free. Yes. So please, if you are getting for free, very good. If you are not getting for free, then you can take subscription to access all the videos. Okay. In that particular video, in that particular lecture series, I have explained stress paths also. I have explained many other things. Okay, because I cannot teach everything, but I have completed the most important portion for your GATE, and other things you can study from the app. Thank you very much. Hope you will solve these 4 questions. Okay, and tomorrow we will study what? Stability of slopes. Yay! Yay! So tomorrow we will study stability of slopes. Please come at night 10:45 p.m. and we will complete the most important concepts, and some side concepts I will not teach. That is available on the app. You can see those videos. Okay, those videos are available. Okay, so tomorrow 1st September we'll covering this. Any doubt you have for anything, you can always contact me. My number is this particular number. Okay, if you have any doubt, please contact me on this number. I am available. Okay, if I'm not taking the class, then I will be available. And homework, 2 homeworks. Okay, 2 homeworks. First is you study that topic, pore water pressure parameters, and write in the comment section whatever you have studied. And 4 homeworks answer I want. Last homework, the gift is already given to the particular person who has won. So this time, okay, this time I will not give prize to a lecture. I'll give a prize to the lecture series. Means what? In Geotech, every day who will comment, okay, so I will give marks. Okay, I will give marks for everyday comments, and then I will add the marks, and then whoever gets the maximum marks, yes, from all the series, from all the lectures of Geotech, he or she will get a prize. So last time I have already given the prize to the person who won it. Okay, and then this time it will be the marks added for all the 4 videos, so that you cover the series. Smart, na? Yes, smart, na? Men of the series, yes. Women of the series also, can be women of the series also. So men of the series or women of the series. So if you comment first, yes, and you answer it correctly, that is also important, right? If you answer wrongly, then negative marks. If you answer wrongly, then negative marks. Okay. If you answer correctly, then I will give you positive marks. And at the end, okay, whoever get the maximum marks, I'll give a good prize. Okay, thank you very much. And the important thing is that if you are solving questions, then this is for revision. Okay, see, these questions I have framed for your revision. Okay, so I'll request that you complete this lectures tomorrow only. Yes, complete lecture tomorrow only, and you know, solve this question tomorrow only, so that what you know, it is fresh in your mind. Thank you very much. Bye bye. Tomorrow we'll meet for stability of slopes. Please come at 10:45. Now I am little tired. Okay, Arsenal, why you are helping your opponents? Okay, don't help your opponents. Okay, tata, bye bye. See you tomorrow 10:45. The time is 1 a.m. Thank you. Bye.